Hello everyone, this is Vasant, 9-pointer at IIT Bombay from the Department of Civil. In previous class, we completed problem 1. Now we are going to deal with problem 2 on axial load. So this is the problem over here. The source is from Gare and Goodnow. If you study if you read the question, the prismatic bar, I already said it yesterday's previous question also. The prismatic bar is the bar which has the constant cross section area. If you see here, the cross sectional area is constant throughout the length. Okay, so that is the reason they called it as a prismatic bar. So as the cross sectional area A and modulus of velocity is E, so only a single value throughout the bar. It means it is made up of homogeneous and isotropic material. And weight W hangs vertically under its own weight. Means you need to include self weight here. So self weight is the load. In this case, self weight is the load. So derive a formula for the downward displacement delta C of point C located at distance h from the lower end of the bar. Okay. See, we already know that in previous example also we seen that delta A is equals to 0, right? Because it is fixed. So whatever load you may apply, but the particles, the material present at the fixed support will undergo no deformation, right? It means delta A will be 0. So delta CA can be written as delta C minus delta A. So that will be is equals to delta A is equals to 0, right? So it will be delta C. What is delta CA? Delta CA is the deformation of the bar AC. So delta CA is deformation of bar AC, right? So it is equals to delta C. So let us go and find out for A. So see, now we need to know what is the load. See, it is self weight, so load is changing throughout the bar. So it is varying load case. You need to consider a small element over here. So let us consider a dx wala element. So this is the element. The length is dx and it is acted upon. Let us assume it is tensile is possible, right? So let us assume tensile. So if you take lower portion, and assume this is the origin and x distance is from here. Okay, then it is at a distance x. This is the lower end B. This is at a distance x, right? So this has some weight Wx, right? So now the n will be this n only because equal and opposite, right? So this is n. So from here equilibrium equation n will be is equals to Wx, right? What is Wx? For whole length it is W. Then for x length it should be Wx by L. That will be is equals to n. So n is equals to Wx by L. So d delta is equals to Wx by L. N. This is n. N into what it should be? It should be Wx PL by EA, right? So the distance, the length is dx and divided by area, E into A, right? So you can integrate it. For delta C, we need to integrate it from H to L, right? Because this is at a distance H and this is at a distance L. A point is at L. So we need to calculate the elongation of AC part only. So the limit should be H to L. So that will give you W L E A integral H L x dx, right? Sorry, this is this is W by L E A integral H L x dx. Okay. So now delta C is equals to W by L E A. That is integral x dx is x square by 2, right? So it is L square minus H square divided by 2 it means W L square minus H square, right? Divided by 2EA into L. This is delta C. Del C is this one. Okay. This is for part A. Let us go to part B. Part B is what is the elongation delta B. So what is delta B? Delta B is nothing but delta B A, right? This is A, right? Yes, delta B A. Delta B A means delta B minus delta A. Delta A is 0, so is equals to delta B, right? This is the case. And we already have the formula. D delta is equals to W by L E A x dx, right? So for entire integration dl, it is for entire bar, so it should be, the limit should be from 0 to L. It's equals to integral 0 to L W x dx divided by L E A. So it will be, what is it? It will be W L E A, and it is L square by 2, right? So W L by 2 E A. You can write it as half W L by E A. So delta B is equals to half into W L by E A. So this elongation is similar to half into a prismatic bar with E comma A as the area and applied with load W. Do you agree? Now let us move to the part C. Sorry, this is part B. So let us move to part C. So what part C says? In part C, what is the ratio beta of the elongation of the elongation of the upper half of the bar to the elongation of the lower half of the bar? Similar thing, we already have the formula. For upper half के लिए what is the value? Upper half के लिए integral L by 2 to L, integration will be Wx dx by Lea, right? So that will be is equals to W by Lea into x square, means L square minus L square by 4 divided by 2. So that will be 3WL divided by 2 into 4, what is 8 EA, right? So for delta upper half, delta lower half के लिए the integral limits will be 0 to L by 2, right? The formula again we have that Wx dx by Lea, that will be is equals to W by Lea into L square by 4 minus 0 divided by 2. That means it is equals to WL by 8Ea, right? So what is beta? Beta is delta upper half divided by delta lower half. That is equals to 3WL divided by 8Ea divided by WL by 8Ea. That will cancel out into 3. Beta is equals to 3, right? So with this we completed part C also. So this is today's lecture. In next lecture we are going to solve again one more problem. Until then, take care. Bye bye from ninepointer.